dimensions. The dimensional formula is represented by, for mass, capital M, for any length measurement L, and for time T. So these are the fundamental units and the dimensions of the fundamental units. For example, as I already mentioned, M represents mass. L represents any length measurement, side, length, height, all these things. T, that represents time. Usually the SI units are kg for mass, length, meter, time, second. Let us consider the dimensional formula. For different parameters. For example, velocity. Velocity is nothing but some displacement divided by time, where S represents displacement. Take down. V, velocity. T, time. S, displacement. So V, the dimensional formula, df of dimensional formula, df dimensional formula of velocity is equal to displacement. Usually it is given in length, meter means length, divided by time t. So it is given as L t power minus 1. The t can be brought here, and there is no m, so you can include m power 0. Anything power 0 is equal to 1. Since there is no mass unit, you can put m0, m power 0. So m power 0, Lt power minus 1. This is the dimensional formula of velocity. Similarly, let us consider the acceleration, A. Acceleration is the velocity, change of velocity, v minus u divided by t. This is acceleration, where A represents acceleration, v final velocity, u initial velocity, t time. So the dimensional formula of acceleration is A is equal to V is L, I mean ml power Lt power minus 1. This is also Lt power minus 1. So you can maintain this as Lt power minus 1 divided by T. So that is Lt power minus 2. There is no mass unit, you can put m power 0. So m power 0, Lt power minus 2 is the dimensional formula of acceleration. Similarly, we can find out the dimensional formula of force, df of force. Force is given by rate of change of momentum, that is m into a. Now m, we can put capital M, and a A we already know, that is LT power minus 2. So the dF of force is MLT power minus 2. And there is a practice, it is always indicated by the square bracket also. Kinetic energy is given by half mv squared. Therefore, forget about the quantities, we have to focus on only the parameters. So m, velocity is LT power minus 1 whole squared. So kinetic energy, dF of kinetic energy is m L squared T power minus 2. So this is the way you have to work out. Similarly, potential energy mgh, where m is mass, g acceleration due to gravity, h height. So dF of potential energy is m mass, g acceleration, so LT power minus 2, h again L. Therefore m L squared T power minus 2. So you can find the dimension formula of potential energy is ml squared T power minus 2, similar to kinetic energy. Power is rate of doing the work, and work is force into displacement. Work is force into displacement. So force we already know. What is the formula? ml T power minus 2 into displacement L. So you can find ml squared T power minus 2 as the dF of W, work. You can find the same dimensional formula for energy also. So after all, yeah, energy is the capacity to do your work. So that is why they have the common unit. And it can also be called a joule. Actually, force is given in Newton. Force equal to MA. So MA means it is given in Newton. N stands for Newton. So W is equal to Newton into meter. S is displacement. So that is given in meter. This Newton meter is called joule. So 1 joule is equal to 1 Newton meter. Therefore, it can have the common unit. That is, it has the joule is a common unit. Joule is a common unit for work and energy. Now power, P stands for power. What is power? Rate of doing the work, W by T. So in that case, what is the unit? Joule per second. And what about MLT? Dimension formula. dF of dimension formula of power is given as work is how much? M L squared T power minus 2 divided by T. So that is equal to M L squared T power minus 1. So this is the dimension formula of power. Minus 3. Because T power minus 1, it becomes T power minus 3. Then density. Density is given by mass by volume. Density. This can be represented as either D or rho. So that is equal to mass is given by M, volume by L into L into L, length cube. So it is given as ml power minus 3. So T power 0. Okay. Area is nothing but length into length. Is it not? Any side into side or length into breadth. So L into L, that is L squared. Similarly, volume L into L into L, that is length cube. So this can be represented as m power 0 L cube T power 0. What about this? Here m power 0 L power 2 T power 0. There is an important concept called dimensional analysis. Dimensional analysis. It is useful to find the unit of given physical quantity. To find out the unit of given physical quantity. It is also used in finding the dimensions of physical constants. Physical constants or coefficients. Now let us analyze some practical situations. Check பண்ணி answer check பண்ணி கையில போடு. சீக்கிரம் வா. So let us have M1 L1 as the CGS unit. Take down CGS M1 L1 T1. M1 is given as 1 gram, L2 is 1 kg, 1 centimeter, t is 1 second. Similarly, in SI unit, m2, that is equal to how much? Kg. L2 meter. T1, T2 second only. Okay. So now let us substitute here. Now the P1 values are so in the P2 value we want to find out this P2. We already know P1, which is nothing but this one, 1.013 into 10 power 6 dyne. So 1.013 into 10 power 6 into and m1 by m2 whole power a. We can put like this, is it not? That is m1 by m2 whole power a. Similarly, L1 by L2 whole power b, and T1 by T2 whole power c. Okay, right? Got it? Now let us replace this, and the value of A, B, C. A is equal to 1, B is equal to, from this we can get it, power minus 1, is it not? So we already know the P value, that is we can write down here, P is equal to ml power minus 1, ml power minus 1, T power minus 2. So from this we can compare A is equal to 1, B is equal to minus 1, C is equal to minus 2. Are you able to follow? Minus 1, C is equal to minus 2. Now let us substitute here. Okay, so let us substitute. M1 is here, M2 is here, L1 is here, L2 is here. So likewise we can substitute everything. Okay, therefore P2 is equal to 1.013 into 10 power 6 into, what is M1? 1 gram you have to mention, and here divided by 1 kg. Are able to follow? Whole power, A means power 1, and L1, what is L1? 1 centimeter divided by 1 meter, whole power minus 1, and then time, 1 second divided by 1 second, whole power how much? Minus 2. Okay, now we have to match the units. So let us match the units. We want to convert this into kg, is it not? Therefore 1.013 into 10 power 6 into 1 kg, 1 gram should be converted into kg. It means 10 power minus 3 kg. Am I right? Divided by kg. Okay. Power 1. 1 centimeter means 10 power minus 2 meter. So meter. Power minus 1. And 1 second is 1 second only. So power minus 2. Okay. So that is equal to 1.013 into 10 power 6 into kg can be cancelled. So you have got 10 power minus 3 whole power 1. So 10 power minus 3. And 10 power minus 2, and this is 10 power minus 1. So it means 10 power plus 3. Is it not? 10 power plus 3. Okay. And you have meter cancel 10 power minus 2 only. Sorry, 10 power minus 2. Because meter cancelled 10 power minus 2. And you have 10 power minus 1 means a plus 2. And then second is cancelled, finished. That is 1 power minus 2, it is meaningless. So 1.013 into 10 power 6 into 10 power minus 3, 10 power minus plus 2, a power m into a power n plus n. So 10 power minus 1. Therefore 1.013 into 10 power 6. This is the pressure in what unit? SI unit. That is Newton per meter square. Okay.
So 10 power
10 power 5. Because 6 into minus 1, 10 power 5. Okay, so this is the pressure in terms of Newton meter per meter power minus 2. Okay.
We show that 10 power minus 2 m minus 1 is 10 power.
10 power minus 2 meter cancel. A power m, this one is a power m whole power n is equal to a power mn. So 10 power minus 2 whole power minus 1 is equal to minus of minus plus. So 10 square. Right? Okay.